So at this point, we want to talk about story problems involving exponential functions. So for this problem, we'll say that 40 grams of a certain material was observed and found to have a half-life of 50 days. We want to find a model function, a of t equals a naught e to the kt, that represents this decay. Then find the amount remaining from the sample after 83 days. So to start off with here, we're going to make note of our function, a of t equals a naught e to the kt. And it's important to note what all of this means. So k is our decay rate constant, and a naught is the initial amount. E is just our natural base, and t is just the variable for the time at which a certain amount was there. So once we find a naught and k, we have the model function, and then we can just plug 83 in for t to find the amount after 83 days. So let's see if we can find the first value. Do we know a naught? Well, we do, because a naught is the initial amount, and the initial amount was said to be 40 grams. So we have a of t equals 40 e to the kt. And now from here we need to solve for k. But the only way we're going to be able to do that is if we find values for t and a of t that we can plug in. So, looking at this problem, notice that it said that a half-life occurs after 50 days. So if we plug 50 in for t, like so, then the only thing we need here is a of 50. What would a of 50 be? Well, that's where the half-life part of this problem comes into play. A half-life means that after this many days have passed, or after this certain amount of time passes, half of the original material will remain. So, we started with 40 grams. That means we're going to have 40 divided by 2 grams remaining after 50 days. So we have 40 divided by 2 on the left equals 40 e to the 50k. Simplifying this, that gives us 20 equals 40 e to the 50k. And dividing each side by 40 to start solving for our k value, we get 0.5 or 1/2 equals e to the 50k. And now what can we do to get k alone from here? Well, we can take the natural log of each side of the equation, because the natural log of e will cancel out this e, leaving us with just the 50k. So that gives us 50k when we cancel out this natural log of e, equals the natural log of 0.5. And finally, dividing each side by 50 finally gives us k by itself. We get k equals the natural log of 0.5 over 50. And if we plug this into a calculator, so just a note on these problems, these particular problems, we're going to go ahead and say that we need to approximate on these. Otherwise, we won't be able to solve them. So, when we plug this into a calculator, rounding to 4 decimal places, we would end up getting negative 0.0139. If you have a TI-83, TI-84, TI Inspire, anything like that, you could just quickly plug this in to verify it. So now that we have our K value, we can create our model function. This is the first thing that we were looking for in this problem. So we have A of t equals 40 e to the negative 0.0139 t. This model represents the amount remaining, A, at a certain time t. Okay, so now to find how much is remaining after 83 days, we just have to plug 83 in for t, which gives us 40 e to the negative 0.0139 times 83, which when we do this would give us 12.6187. Now, for when I teach, this is perfectly acceptable to me. These types of problems, there's so much rounding going on. I'm okay with this. But in general, for most math courses, this would not be an acceptable answer because this has introduced rounding error. You should never round until the last step of the problem. But notice we had to round our K value. And because we rounded our K value, when we plugged in 83 into this model function, it gave us this. But in reality, if you were to go into your calculator and plug in the natural log of 0.5 divided by 50, let me go ahead and show this really quick. So the natural log of 0.5 divided by 50, you would really get negative 0.01386294 and so on. This should technically be the value that's being multiplied to 83, then plugged into the exponent of e and multiplied by 40. And if you use that value, then what you would really get is 12.6576. It's not a huge difference, but it is technically there. It's a few hundredths of a gram of difference. So in the majority of math courses that you'll ever come across, this is what you should technically use, the exact value of K. But for when I teach, I'm okay with this value. It's not a huge difference, and it just causes a lot of issue when you're trying to learn the actual method to just have to remember that weird decimal process. So we'll go ahead and put this into an answer, a sentence answer, because this was a story problem. So after 83 days, we have that 12.6576 grams of material will remain. And that is our second part of the answer, and now this problem is completely solved.